In the afternoon when the sky is very clear, okay, what color is the sky? Blue, correct, no? And in the morning, okay, that is during sunrise or sunset, what color is the sky? Orange or orange. uh, why does sky have all these colors? Or does it have different colors? Does it have a mode where it can change colors? Afternoon, blue, morning, red, orange. Why does sky have all these things? Does the sky have all the colors? It is not the sky that has the colors. It is the color that we see. Okay. In order to explain this, okay, I should explain you one concept. That concept is called as scattering of light. The concept is called as scattering of light. So what is the scattering of light? Uh, have you seen scenarios, especially during the evening or something? In your home, you have windows, right? Windows will have grills, small openings, correct? No? So one beam of light will be coming through the window, and in that dust particles will be dancing here and there. Have you seen that scenario? Okay, that exact thing, okay, is due to scattering of light. Okay, what is the scattering of light? I'll just explain and I'll do a demonstration also. That is, when light, okay, let me consider light as a wave. Okay, light is a wave. Okay, light, when it goes and hits any particle, okay, generally if it hits a very big particle, what will happen? Like a mirror, light will go and hit a mirror. Okay, what will happen? It will reflect, correct? No, it will come back to us. That is a definite. Like if light goes and hits like this, it will come back in this direction. For big particles, light behaves like this. But for very tiny particles, light behaves in a different way. Probably light has a soft corner, I don't know, but light behaves in a different way. What happens is, when light hits tiny particles, instead of just reflecting in one direction, okay, it will reflect in all possible directions. What will happen? When light hits a big particle, a macro particle like a mirror or some object, it will reflect in one direction. If light goes, it will bounce back in one direction. But when light hits minute particles or mini particles, very small particles, instead of reflecting in one direction, it will reflect in all possible directions. Okay, this is known as scattering of light. So what is scattering of light? When light hits very small particles, it will reflect in all possible directions. That is known as scattering of light. So what happens because of scattering? Because of scattering, these particles look like they are glowing. Because of scattering, these particles look like they are glowing. And that is why you can see the path of light. The same thing what I told you, when light comes to the window, you can see those small particles floating in it. It's like those particles are glowing. Because of those glowing particles, you can see that line. Otherwise, even now there is light, right? Even now you have light. Can you see the path of light? Not there, correct, no? But if you make this room dusty, then you can see the path of light. Okay, I'll do the demonstration now. Okay, now you have this green laser. Okay, you can see the point there. Can you see the line? It's visible. Okay, but it's like okayish, like it's not that bright. Okay, I'll give you a comparison. Now we may not have a comparison, but now I'll do something. Tell me which is better out of these two cases. Which is better? Just hold on to this one. Let's play with fire now. Where is my this one? I got this letter just for experiment purpose. Don't think otherwise. Okay, now can you see the light when it's passing through that smoke? Is it better than this? Is the visibility better there when it is passing through the smoke? This is scattering of light. When light is hitting the particle, instead of just reflecting in one direction, these are smoke particles are very small. It is reflecting in all possible directions, because of which it is glowing, and because of the glow, you see the path. Is it visible? What do I do with this? What is this called now? Scattering of light.